Today we are going to be using some multiplication properties of exponents, so I want to review some vocab very quickly. First of all, a coefficient is a number in front of a variable. I'm not sure that space got in there right. There we go. A base then is a number or a variable with an exponent. So it has an exponent on it, and it can be either a number or a variable. Oops. If I grab the right part. And then an exponent tells you how many times the base is repeated. Okay, so if we go over here and we just name some of these, and I'm just going to use C, B, and E for coefficient, base, and exponent. My coefficient here is equal to 13 because it's a number in front of the variable C. The base here is C because the base has the exponent. The exponent is 5. So if I look here, it separates it here. So 13 does not have an exponent of 5, only the C. If I look at this next one, there's no coefficient here because there's no variable. My base is equal to 5 because it has an exponent of 4. And on this last one, the parentheses are very important. That means this whole thing in here is the base. So the base is 2g because it's in parentheses, with an exponent of 6. So in this case, 2, even though it's in front of a variable, is not a coefficient because it's part of the base since it's included in the parentheses. So example number 1 is multiplying powers. It says rewrite each expression using each base only once. Basically the rule here is whatever's the same is the part you keep. So if I look here, the base of 11 is what they have in common. So I'm going to keep the base of 11. Since it's times, you actually add the exponents. So 4 plus 3 is 7. So my answer is 11 to the 7th. Again, you keep the part that they have the same. So again, the bases here are both 5, so I'm going to keep the 5. And if it's multiplication, you add the exponents. Negative 2 plus 2 is 0. 5 times 0 is 1, or 5 to the 0th power, sorry, is 1. So our rule would be you keep the part that they have in common. If it's multiplication, you add your exponents. And this should also be a review from last year because we did these rules last year as well. This now is going to have expressions, so it has more parts to it. So if I look here, 2 and 3 are the coefficients here, so 2 times 3 is 6. Not sure what's going on with my pen there. The next part I have n to the 5th times n to the negative 2nd. Those both have the same base of n. 5 plus 2 is 3. So I get 6n cubed. On our next ones, our coefficients are 5, 2, and 3. So 5 times 2 times 3 is 30. And then I have to look at the ones that have the same base, an x and an x to the 8th. If this x does not have an exponent, the exponent is actually 1. So I keep the base of x because that's the part they have the same. 1 plus 8 is 9. And then if I look there, I also have y to the 4th. There's no other y's, so that stays y to the 4th. So my answer here is 30, x to the 9th, y to the 4th. Example 3 is multiplying numbers in scientific notation. So you multiply the front numbers, or the part that represents the A. So 7 times 4 is 28. Times, if I look at the next part, they both have a base of 10, so that's the part I'm going to keep. Multiplication, you add the exponents. 2 plus 5 is 7. It says to write our answers in scientific notation. Well, in order to be in scientific notation, this has to be less than 10. So I need to move my decimal. So it would be 2.8 times 10 to the 8th. Because I moved it to the left, so I need to add 1 to the exponent. So 2.1 times 10 to the 8th. Our last example here is the real world problem solving. It says a human body contains about 3.2 times 10 to the 4th microliters of blood for each pound of body weight. Each microliter of blood contains about 5 times 10 to the 6th red blood cells. Find the approximate number of red blood cells in a body of a 125-pound person. So this is how many microliters of blood for each pound of body weight. Well, if I'm 125 pounds, to figure out how many microliters of blood I'm going to have, I would take 3.2 times 10 to the 4th times 125. And that's going to give me my microliters of blood. But then every microliter of blood contains 5 times 10 to the 6th amounts of red blood cells. So then I'm going to take that times 5 times 10 to the 6th to figure out the approximate number of red blood cells in a 125-pound person. So now that I'm going to multiply those, I'm going to do all my numbers, coefficients here. Or actually, they're not coefficients because there's no variable there. So 3.2 times 125 times 5 gives me 2,000 times 10, and I'm keeping the 10 because that's the base they have in common. Multiplication means you add the exponent, so it'd be times 10 to the 10. Okay, well, I need to write this in scientific notation. So I need this number between 1 and 10, so I'm moving it over 3 spaces to the left. So that means I add 3 onto my exponent. So I get times 2 times 10 to the 13th red blood cells. Go ahead and complete the quick check and then look at your schedule for the assignment.